So the original theory, the idea of continental drift, became known more as the theory of plate tectonics now, because we found out that there are basically 8 major plates, and then there's a bunch of smaller ones in here, but basically 8 major ones. There's Eurasia, Indo-Australian, would be kind of around India and Australia are hooked together on the same one here. The Pacific plate, which is the very largest one, notice it's an ocean, and you notice that is the biggest ocean. Section of the ocean on Earth. The North American plate, which includes Alaska, part of Russia and Greenland. Over here, the Eurasian plate again, sticking up over here. African plate, South American plate, and the Nazca plate down here by South America. And then, of course, Antarctic plate down at the bottom. Now, the idea is not just that the continents move, but actually that they are on these big plates or flat pieces of lithosphere that are attached. And some of these, like the Pacific, is almost all underwater, completely ocean. Others have continent, like Australia, but also it has part of India, so part of ocean and continents. So the idea of just continents drifting, actually, because that's all they could see at that time, were the continents above the surface. Now, the idea is that there's huge sections of plates. Now, some things that contributed to this idea, for example, and it really brought a lot of things together. It explained the seafloor spreading. It explained why there are different ages, different magnetic fields in rocks formed underneath the ocean. For many years, there's what and still is called the Ring of Fire, which is around the Pacific Ocean. You've got up here in the Aleutian Islands are always having earthquakes and volcanoes. I have a notification service that tells me when there's new ones bigger than 6 point something, and a lot of them are up here on the Aleutian Islands, on Mount St. Helens active volcano, as well as a lot of the mountain ranges along the western coast of the United States. You have are volcanic in origin. You have the Andes down here in South America, and once again you have a lot of earthquakes all along. And it was called the Ring of Fire because you had all these earthquakes and volcano activity and stuff around it. And now it would explain that if they were all at the edge of a continental plate that was either moving under or over various things, and that would explain why you were having these earthquakes when the plates would rub together, or when they would one would go underneath the other, and that would cause part of that crust to be melted and then come back up as a volcano, and so forth. And so it explained a lot of those type of things, why volcanoes were where they were. On the other hand, out in the ocean where these plates met, you have very low earthquake or volcano activity because these plates are moving apart from each other. Okay, the Atlantic Ridge here, coming down here, the Mid-Atlantic Ridge, they're separating, so they're not rubbing against each other, so it wouldn't be causing those earthquakes and volcanoes and mountains that are formed from those volcanoes to appear there. All right, and so plate tectonics made all this stuff, the ideas of continental drift, the idea of the ocean floor, what we found out about it, and the patterns of earthquakes and volcanoes and all these things started to make more sense. And so we have, basically, we have 8 major plates, we think. These are part of the lithosphere. But remember, the lithosphere is the crust, and the first part of the more dense layer, which is the upper mantle. All right, and they're sliding around on top of the asthenosphere, which is the lower part of the upper mantle, and it's kind of it's solid, but it flows and moves gradually, and we think these crust layers are moving across there. Now they may be talking inches per year. It's not very much, but over time that's going to add up to be a fair amount of time. Okay, and so some of these are moving at different directions. Like we said, the mid-oceanic are moving apart, so that's why you have more. Where they're colliding or coming together, a lot of times that's where you have more volcano activity, or especially earthquakes, because they're coming together, rubbing against each other. Okay. In general, continental plates, like say the North American that has that, is going to move slower than the ocean plates. Remember, ocean plates are much thinner, even though they have denser materials, but they tend to move faster. Okay, the continental plates tend to move slowly. All the interaction, all the action, where is the action? Well, the action is right here along these edges. Okay. And so along the plate boundaries. So plate boundaries are where we have a lot of this earthquake, volcano, and even creation of mountain ranges and stuff, usually along plate boundaries or former plate boundaries. All right. And so where they run, they're either making new lithosphere, new crust, like where they're coming apart. Where they're coming together is where you destroy some of the old either ocean or continental crust. All right, and that's basically what plate tectonics is. It's the idea that it's not all solid, but that there are different plates and that they're moving on the asthenosphere, the liquid convection currents underneath are causing that motion. Now, obviously there are different plates moving in different directions around the globe, so there are different types of movement, but basically we would say that there are three types of plate boundaries then that we want to talk about. The first, if I can pull my picture down here, there we go. Okay, the first would be when the plates are moving away from each other. Okay, as you can see by the white arrows here, this one's moving this way, this one's moving apart. Okay, and this would be like the mid-oceanic ridge that we talked about. You have the asthenosphere with magma or almost semi-melted down here, and as the plates pull away from each other, then that makes a weak spot here, and this more liquidy almost melted. As it comes up to the surface where there's less pressure, it begins to melt, and it fills in this. And so as they pull apart, new stuff bubbles up. And because it's bubbling up or rising and then hardens as it comes up, it makes these ridges in the middle. And that's the mid-oceanic ridge that we're talking about. Okay, and so they're divergent because the plates are diverging or going apart in different direction. Okay, these are going to be places where you get new crust being made. Usually, like I said, oceanic crust, but it's going to be new crust being made as magma bubbles up from below. All right, and it fills in those gaps. Now, in the ocean, like I said, we call this either seafloor spreading because it's spreading out, okay, or it's called a mid-oceanic ridge. So that's if it happens in the ocean, but it can also happen on land where plates begin to pull apart. And if it's on land, then it's called a rift valley. One of the famous rift valleys is in Africa. There's a large rift valley running through part of that continent. Okay, and that rift valley is also where there are lots of magma activity, and the heat and pressure from that magma coming up has created diamonds and so forth. Okay, sometimes if it's on land, then you would expect to have perhaps some shallow earthquakes. Okay, because they're not pushing against each other, but when they pull apart, obviously there's going to be some friction as it moves apart, and so there are some shallow earthquakes and stuff, but not a lot of activity around these areas because it's more peaceful. They're going apart from each other, so they don't cause any. They're not pushing against each other and building up enough pressure to cause really big problems. Convergent boundaries, though, on the other hand, are where things are coming together. They're running into each other. Okay, these are going to be a little more violent because now they're crashing into each other. Just like if you had two cars pulling apart from each other, that's not going to be that big a deal. But when they're crashing into each other, that's going to cause problems. Well, the same thing here. All right, one plate will have to go underneath the other. Okay, now it will also tend to pull this one down a little bit with it, but generally one plate has to go through underneath the other. And we'll talk more about which ones do that here in a minute. But as they're coming together, they converge it. As this comes down here, it begins to melt. Okay, and so you start having this magma a lot of times that will rise up toward the surface again. All right, as this one is getting subducted or going below the surface. Okay. Generally speaking, we talk about ocean going underneath continent, and the ocean continent being denser and thinner goes underneath the continent. All right, and so it tends to destroy the ocean crust because as it goes down here, it gets melted, and so it's being recycled or destroyed down there. Whereas the continental crust is being deformed, being pushed down or pulled with it, but it doesn't usually get as destroyed as that. Now, because of that, you have deep earthquakes as it's rubbing down here. A lot of times, these are going to be more your deep and therefore more serious earthquakes. Okay, they're going to set off bigger shock waves, seismic waves, and so forth, and so you're going to have a lot bigger earthquake as a result of those. All right, which brings us to our last type of boundaries, and those would be transform boundaries. Now you'll notice it's kind of like the stresses we talked about. You have stresses where they You had compressional where they come together, that would be like convergent. You had tension where they're pulling apart, that would be like the divergent. And then we had slip strike faults where they're going side directions. And so this would be called, when it's happening on large boundaries, we call plate boundaries, we call these transform boundaries. Okay, transform boundaries. And transform plate boundaries, since one plate is going this direction, one's going this direction, none of them is being forced down or apart, so there's not much magma, or also magma still occurs below the surface, so there's no generation of new magma. There's no new plates being formed or destroyed for the most part. There's a little bit, but mostly they slip as they slide past each other. And kind of like we talked about with strike slip faults, as they move across, if they catch on each other, then it catches, and while it's catching up, it's building up pressure, building up pressure, building up pressure. When it finally gets enough pressure to slip past it, then that's what causes the earthquake. Okay, that movement of the earth is because they were caught on each other and they built up pressure until they could slide past. Once they slid past, then it releases all that energy, which causes the earthquake. All right, so these are primarily associated with a lot of the earthquakes that we have. San Andreas Fault again in California is an excellent example of one of these, where they're going side by side each other, but when they let loose, break loose, that's what causes the earthquakes. And California has had some doozies, and they're kind of overdue for a big one. Whether it'll happen or not, we'll see, but they've been predicting they should have a big one sometime soon, and we'll see. It's kind of overdue already. All right, before we go to our last thing, we're talking about convergent. Let's look at, these are some pictures from divergent ones. Okay, if you have continental crust, if two plates are coming together, pulling apart, that may allow magma to come up, which may cause some kind of upwarping, but then as it breaks and cracks and fractures, it pulls apart. And so these would be examples of divergent boundaries. Okay, they're pulling apart, and like we said, on land, very often that results in new larvae being formed down here, but you get a valley or a low spot basically. Whereas if you have in the ocean, when they separate, here's your regular ocean, it comes up here, it's upwelling of magma, and the current, convection current, remember, pulling these opposite directions, so they pull it apart, and as this upwelling of magma comes up, it comes up and hardens, making these ridges in the middle. And so that's kind of how you can see how the divergent boundaries work in ocean versus on land. Okay, I should have shown you those earlier, but that's okay, we're getting there. Now we want to talk a little bit more though about convergent, because a lot of the excitement happens. These are relatively calm occurrences when you have rift valleys and mid-ocean. Yes, there may be some lava flowing under the water, and there's some earthquakes and stuff associated with that, but for the most part, most of the action happens when they come crashing together. So we're going to look at type of convergent boundaries on this rest of this video and on the next. Okay, first one we're going to talk about is ocean to ocean. Okay, we usually don't think about this as affecting us as directly because it's underwater, we don't see it, but ocean to ocean plates, when they come together, all right, one of the ocean plates, since they're both kind of equally dense and equally thin, one of them will subduct under the other. Notice that even though this is the subduction zone right here where it's being subducted, notice that this plate is also being kind of bent and deformed also. And because of that, you have this V shape here we talked about before, and that's the trench. And some of these trenches are very deep. The Marianas Trench is the deepest place on the earth, and that would make some of our on-land valleys and stuff like that look extremely small. The Grand Canyon wouldn't be anything compared to it. Now, as this ocean crust gets subducted underneath, it begins to melt. And as it melts, you have magma coming up to the surface, and these are called hot spots. Okay? And above the hot spot, then it may form a volcano. And if a volcano is deep enough, or high enough, I should say, it may stick up above the surface, and we would call that an island. All right. Now, as the plate moves, different parts, or maybe say it's moving this direction, different parts may be above it, and you end up with a chain of islands, and we'll have to talk more about that on the next video.